Hi, and welcome to the second instalment of the Functions and Relations revision. First question we have here, if f of x is equal to 4 take away 3x squared, find f of 2a. That basically means we have to substitute 2a in everywhere we see x. So, f of 2a is equal to 4 take away 3. I'm going to write where x is in brackets, so 2a has replaced x, needs to be squared. And we use our order of operations. We have to complete the bracket first, so 4 take away 3 multiplied by. We have to square the 2 as well as the a, so 2 squared is 4 and a squared is just a squared, so that'll be equal to 4 take away 12a squared, and that there is your answer. Let's move on to the next question. State the implied maximal domain of the function. So when we're looking at an implied maximal domain, we're basically going to be looking for any natural restrictions that there could be within the function. In this instance here, we have a little expression on the bottom of the fraction, and that there we're going to have issues if that is equal to 0. So basically what we need to do with this one is we'll get that bracket x plus 4 squared equal 0. That's going to be the problem we have because we can't divide by 0. Now if I want to get rid of that squared sign, we square root both sides, which will leave us with x plus 4 is equal to square root of 0, still going to be 0. Take away 4 from both sides, we'll have x is equal to negative 4. So what that tells us is that x can't equal negative 4. So the answer that will give us for our domain is we can have any real number, but we need to exclude the value of negative 4. Because if x is equal to negative 4, we get an undefined value for the function. Let's move on to the next question. Now, state the range of the function where we have a domain of negative 2 through to 7 maps onto any real number, where f of x is equal to 5 take away x. We're dealing with a linear expression here. So basically what we need to do is we find the y values that correspond to negative 2 and 7 as the limits of the domain in the x. So if x is equal to negative 2, then the function of negative 2 will be equal to 5 take away negative 2, which equals 5 plus 2, which is 7. Similarly, if x is equal to 7, then the function of 7 will be equal to 5 take away 7, which is equal to negative 2. So they're going to be the limits that we have for our range, with this being a linear function. So the way that we do this is we would state the range as going from the smallest to the biggest. So the smallest of these values is negative 2, and the biggest is going to be 7. Now we need to work out if we have square bracket or round bracket corresponding. So when we looked at the original question, we had square bracket corresponding to negative 2, so that one then means that this would have to be a square bracket. And we had a round bracket corresponding to the 7, so this would have to be a round bracket. So it's not allowed to equal negative 2, but it starts at -2 as the lower limit, and it can equal +7. The other way that that could be written would be -2 y7. That's basically what it means, but we'll keep it in the bracket form like we have there. We'll move on to the next question. What is the range for this particular function where we have a domain of -2 through to 5 mapping onto any real number, and this function is x squared take away 5, so we have a quadratic. So we need to actually consider the shape of the graph for this one to start with. So just a very quick sketch of what this is going to look like with our x and our y, and I'm not going to worry anything at all about scales or anything. The rough shape of the graph is going to be a parabola like so, which passes through at +5. So it's an x squared graph which has been translated up 5. Now what we need to do is apply the domain restriction that we have on there. So it goes from -2 through to +5. So that's going to correspond to a value here. It'll come through and it'll go up until we reach our 5. We have a square bracket at -2, so I'm going to put a little filled in circle there, and a round bracket at 5, so it could be an open circle there. So that's basically the graph that we're looking at, and what we need to think about with our range is the lowest point to the highest point. So the lowest point here is at 5, and the highest point here is at the function of 5. And that there is our range. So what we need to do is actually evaluate what the function of 5 is, and that will be equal to 5 squared plus 5, which is equal to 25 plus 5 equals 30. So that tells us that the range for this particular question is, now we've got 5 as our lower limit, 30 at the upper limit. Now the question we'll ask ourselves is, does the graph actually equal 5 in the y? So does it touch 5 and equal it? And the answer to that is yes, because when x is equal to 0, then y coordinate for that one is 5. And does it actually equal 30 at the top, or is 30 our limit? And that's corresponding to our round bracket and domain, so we're going to use a round bracket again there, because that's the limit, but it doesn't actually equal that value of 30 in the range. Let's move on to the next question. What is the range of bracket x minus 2 all squared plus y squared equals 16? This is not a function, it's a relation, and it's a circle graph. To quickly sketch this graph to see what it's going to look like with our x and y like so. It's a circle which has a centre of, x is shifted to the right by 2, so it has a centre there and it doesn't go up or down, so that's going to be the centre of the graph, and x is equal to 2. And the radius is equal to the square root of 16, which equals 4. So from 2 in every direction it goes out by 4. So that'll mean that we go across to 6 and we go back to -2 with a rough idea of a circle like so. And we'll continue these y-axes a bit more. The bottom of that is going to correspond to, not the best of circles, is it? But anyway, the bottom of the circle, because it goes down by 4 and it goes up by 4, So the bottom of the circle would be at -4, the top of the circle would also be at +4. So that tells us that the range for our graph is from -4 through to +4. And does it equal those values? Yes, it does in both instances. So we're going to use some square brackets to represent that one. And that there is the last of the questions that we have for this particular section.